In this video, we'll be learning about how to evaluate LLM chain performance and also agent performance, along with how to create custom prompts both for chains and for agents. Let's begin with a quick demonstration, first with a regular LLM chain. We have two examples which we know the answers to. We're going to get responses from the LLM and compare the results to the responses. This way we will be able to rate the results. Let's run this and see what happens. As you see, our first example includes the question: Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? The real answer is 11. And the LLM returned to us answer 11 tennis balls. And then the evaluation, which we have imported here, QA eval chain, evaluated, which also uses a large language model, as correct. So the answer returned to us from LLM is correct. The second question is the real answer is no, and the predicted answer is no. It comes with an explanation, and then we evaluate this to be correct as well. Evaluation is important if you're building systems, especially for production. You need to have some way of automatically evaluating the performance of your models against the data set or something like that. Now let's take a look at the demonstration for an agent. This agent actually is going to be searching the internet with the SERP API tool. It's Google search. We will also be talking about custom prompts and how to actually import data sets. In this case, we are importing the truthful QA from the huggingface datasets, and we are picking a few examples out of it, and we are feeding a custom prompt. So in this case, we have the actual answers to these questions, and our LLM is going to, at times, use SERP API to do a Google search and give us a predicted answer, and we'll have a prediction grade by similarity. Let's run this. As you see, we download the data set, we enter agent executor chain, we make an observation, and it wants to do a search. It gets the search result, and then it gives us the final answer. It does this again and again automatically for about three or four data set inputs. After that, it evaluates the examples. Example 0, here's the question, here's the answer, here's the predicted answer. The grade comes with reasoning and similarity score. How similar is the predicted answer to the real answer? In this case, it says the predicted answer is not factually correct in comparison to the real answer. In the second example, again, it says it was incorrect. The third one is not very similar either. I've seen that actually doing Google search reduces the performance of these LLMs. We'll talk about this when we get there. But let's just take a look at the code and see how we can build something like this. I said that Google search reduces the performance of LLM models. I should have actually said it reduces their performance during evaluation. So I'll just explain how this all works, and you can be the judge of it yourselves. Let's begin by installing our environment. I'm going to create a new terminal, and I'm going to come to this drop-down menu and select command prompt. And from my base environment, I'm going to type conda create -n eval is going to be the name of the environment, Python equals version 3.10. So we are creating a new conda environment named eval with the Python version 3.10. And I'm using miniconda for environments. You can use anything you like. I'll put the link in the description. We will also be pip installing Hugging Face datasets. So this way we can actually use datasets from Hugging Face. Our requirements are going to be Langchain, OpenAI, and datasets. Next, we activate our environment. Conda activate eval. We are in our eval environment. Pip install Langchain. After that, we will pip install OpenAI, and then we will pip install datasets. Datasets is necessary if you want to use Hugging Face datasets. In the agent evaluation, we are using the truthful QA dataset from Hugging Face. Next, pip install OpenAI, and finally, pip install datasets. I forgot to mention that if you want to be able to do Google search with SERP API, we also have to install Google search results, which is for SERP API. Pip install Google search results like this. And after that, okay, our environment is done. Sorry about that. We need Langchain, OpenAI datasets, and Google search results for SERP API. After that, go click Ctrl-Shift-P, Python select interpreter, select your environment. Let's examine our code for a simple eval chain. We are importing a prompt template, Langchain, OpenAI, and the QA eval chain for evaluation. We are defining a very simple prompt with a prompt template. It's just, there's a question and just an answer after that. Question is dynamically inserted as an input variable, which is the question. We are defining our large language model as OpenAI model text-003, temperature set to 0. And our chain is an LLM chain, LLM being the M, which we have defined right here. And our prompt is the prompt, which we have defined right here. Now we are manually defining two examples in square brackets because it's a list, and the examples themselves is in a dictionary format. The key is the question, which is the question right here, and answer is the value, which is like this. You have to follow this format. And the second question is separated by a comma, again, is a dictionary value, key and value, question and answer. After that, since we have defined our chain, we are assigning a predictions variable to chain.apply examples. This is the syntax. This will make it go over all the examples and generate for each prediction, because as you see, our question is going to be the question and the answer is going to be the return output from the LLM. And after that, we are defining another LLM, which is OpenAI. And because our QA eval chain, which we have imported up here, is going to use our OpenAI LLM to evaluate the result that is returned from GPT-3 with the result which we have from our examples dataset. So we are actually using LLM to do the evaluation for us. That's why we define an eval chain with the QA eval chain. And we are using this LLM to do the evaluation for us. And then we say, eval underscore chain evaluate the examples which we have defined right here, predictions which we are receiving at the end of our chain, question key is the question, answer key is the answer, prediction key is the text. You have to define it like the syntax for it. After that, we define a graded outputs with eval chain.evaluate, again examples, predictions, question key is question, answer key is answer, and prediction key is text. I believe this line is redundant, but anyway, because all we need to do is just assign it to the graded output. And then we do for I an example in enumerate examples. So we are looping over the examples, and then we are printing the example, which in a loop fashion, and then we are printing the question. We are printing the real answer, and we are printing the predicted answer, which we receive from the LLM. And we are printing the predicted grade, which is the result of the QA eval chain right here. Now, if we run this again, this will make more sense. As you see, our first example was Roger has this question. Real answer was this. Predicted answer was this. And the evaluation grade was correct. Second question, second answer. The second answer from the LLM prediction. And the predicted grade was correct. So this is how you can use evaluation on a simple chain. Let's take a look at how we could have used a custom prompt. I just want to quickly mention that we are defining the LLM twice. I just want to let you know that this is redundant. You don't have to define it twice. I actually just changed the name of it to LLM eval and assigned it right here to QA eval chain. But you can use two different LLM definitions if you want to use a different temperature, for example, for eval chain than the prediction chain. Just wanted to let you know. So we are going to be defining a custom prompt. Our prompt for the prediction chain is going to remain the same. It's just a question and an answer, right? But we are going to be modifying the prompt for the eval chain. And to do that, I have pasted this prompt template right here under the predictions. So we are defining a custom prompt here with underscore prompt underscore template. Okay, this is our custom prompt. You are an expert professor specialized in grading students' answers to questions. You are grading the following question. Query is an input. This is the question. Here's the real answer, which is the answer that we know for sure is to be true. You are grading the following predicted answer. Result is the result that we get from the prediction chain. And then we prompt the LLM to use step-by-step reasoning to grade the answer. Be very critical, write your reasoning before you grade the answer, and then grade the answer on factuality, giving it a score from 0 to 10. Okay, and then we are defining a second prompt with the prompt template, input variables, in this case, the query, answer, and the result. And now, after we do this, all we have to do is, where we are defining the QA eval chain, we have to say prompt, okay, equals to prompt. Now we are using the custom prompt. And as you see, when we run this, our first example now, the same question, same real answer, same predicted answer, but the prediction grade now includes a reasoning and a similarity score. Same for the second one. The real answer, predicted grade includes a reasoning and a similarity score, and then a grade at the end. So this is pretty wonderful. Next, let's take a look at how we can evaluate agents that are using tools. I just want to mention you have to set your OpenAI API key and SERP API key for this example in your environment variables, or you have to define them in the code. The same is true for OpenAI for the chain evaluation as well. Okay, so we are importing a prompt template. We'll be defining a custom prompt. We don't need the chain. We are importing OpenAI. And we are defining our large language model to be TextDaVinci 003, temperature set to 0. Then we are importing load tools to be able to load tools, such as SERP API. And then we are importing initialize agent to initialize our agent. And then we are defining our tools with the load tools, and the syntax is like this, in square brackets is a string, SERP API. Our large language model is our LM, which we have defined right here. And our agent is going to be defined with initialize agent, which we are importing. And we are assigning it the tools, which we have defined. In this case, only SERP API, Google search. And agent is going to be using the default zero-shot React description from Langchain. And we are setting the verbose to true so that we can actually see the thought processes printed in the terminal. You can set this to false if you don't want to. As I mentioned, you need to pip install datasets from huggingface. We have done this already. You can also test it with this command if you want to. Then from datasets, we are importing load dataset. And then we are assigning our dataset to be the load dataset, truthful QA generation. This is now we have loaded our dataset, huggingface. And then I am creating an example list from this dataset, and I'm assigning it a list from the dataset validation. I'm choosing two examples from validation, and I'm just choosing a few examples by way of indexing. This is just a Python property. I'm just choosing examples from 5 to 8, 3 examples, 5, 6, and 7. And then I'm assigning an example to an empty list, and I am looping over the examples list, and I'm appending to the empty examples list the examples as a dictionary, question being the key, and then the answer to the question being the value, and then answer being the key, and then the answer from the dataset is the value. As you remember, this is how our examples was defined. It's a list of dictionary key value pairs. This is why I'm actually looping over the dataset and recreating these examples. Then you can print out just to examine how it looks like. Then I am creating an empty list for predictions. And then since we have created our examples list, I am looping over the examples list, and I am appending to the predictions list as a dictionary, as the text being the result of what our agent returns. And we are inputting the question in this case as what the agent will process as the query. And then we are simply printing the predictions just for observation purposes. Now we have our predictions for our example questions from our dataset, from our agent. Now we are importing the QA eval chain and the prompt template again, and our custom prompt is going to be the same prompt which we have used earlier. You can read through it. It takes in a question, it knows the real answer, and it also wants the result from LM to be graded, again with a reasoning and effectuality score. We are defining our prompt with the prompt template with input variables, query, answer, and result, and our template is the prompt template which we have created right here. After that, we are defining our eval chain to be the QL eval chain from LLM, like this. Our LLM is the LLM we have defined. We can define a separate LLM if you like, as we talked earlier. Prompt is the prompt we have defined. And then we are assigning to the graded outputs the result of our evaluation. Eval chain.evaluate out of examples, the predictions, question key being the question, answer key being the answer, prediction text being the text. As you see, the text is assigned right here. We are assigned the predictions actually has the text as the return of our agent's evaluation. Then we simply print out the results with enumerate just like we did earlier. Okay, we are printing the example, the question, the real answer, predicted answer, and predicted grade. Let's just run this one last time. By the way, I will have all this code for my Patreon supporters available for download. Okay, we are now going to do the agent executor chain 3 times over for each example question. And at the end of it, we are doing actually Google search, as you see. And then we will get the evaluation right here. The evaluation of example 1. This is the question. The real answer is right here. Predicted answer was this after using the Google search. And this is the predicted grade, 2 out of 10. And the reasoning is right here. Same for the second question. And for the third one, I realized that the Google search can return a bunch of different results, and then it can skew the predicted answer from the real answer. So I'm not saying that Google search reduces the effectiveness of agents, but it becomes really hard to get it really close to the real answer, which you're attempting to maybe try to compare it to. Just keep that in mind. I hope you found this useful. I will slowly scroll over the code, and I will have this available for download for my Patreon supporters. If you like the quick ability to be able to download, please join our Discord as well. If you have any questions, let us know in the Discord channel. I'll put the link in the description, or just make a comment under the YouTube video. Hope to make more videos about these stuff, really exciting new technologies, and see you in the next video. Take care.